Okay, so when it comes to the vertical alignment, the first thing that we are going to do is we are going to raise this datum elevation. Okay, so we are going to raise this datum elevation. How we are going to do that? You can select this one, the grid, go to profile view properties, and then go to elevations, and here it is automatic height 80 into 26. What you can do is you can select this user specified height. Okay, user specified height, and then insert 12 here, apply. Okay, right. Now can you see, now it is being elevated. Now what about this upper limit? Upper limit, of course, if you want to make it 30, you can do. How? Select the grid, go to profile view properties, and go to elevations. User specified height is 12 to say 30, or you can try 16 to 30. That will be pretty enough, I think. Okay, I think it's enough. Okay, right. Now after that, what we are going to do is we are going to start designing the vertical profile. For that, there is a tool bar given in the Civil 3D. For that, you have to get profiles. Now earlier we got create profile from surface, right? Now we are going to get create profile by layout. Okay, create profile by layout. Now it says select profile view to create profile. Select profile view to create profile. So you select this profile view. And then there comes a dialog box. Create profile, draw new. Alignment you can't change. It is DZL because it is the one that was based to this profile view. Then the name, usually we give FG, finish ground. And profile style is UM. Okay, and the profile label set is also UM. These are some customized label sets. Then press OK. Right, now you can see there came a dialog box. So using this dialog box, we can start designing the vertical line, right? Vertical line. The very first thing that we do is we are going to draw gradients, matching gradients, right? But one thing is you have to understand, when you are drawing gradients, you have to keep in mind what is the minimum curve length. So what is the minimum curve length? According to the book, it is 50. So if you are going to draw one gradient like this and the other one like this, then of course you can have 50-meter curve here. 50 is measured horizontal wise, okay, not along the profile view, horizontally. Okay, do you understand what I'm telling? So it is measured along the horizontal alignment. So these are the horizontal alignment labels. So you are measuring it like this, not along the vertical profile. Okay, that is one basic thing that you have to understand, right? Okay, so we'll start. We'll go to draw tangents. Now what I'm trying to do is, first I'll draw some gradients to match the existing ground, and then later I'll elevate it considering the pavement design. As an example, now you can say your pavement design will say it is wearing course 40 millimeter and binder course 60 millimeter. So on top of the existing profile, existing ground, that is 100 millimeter. So what I'll do is I'll match this one to the my design profile to the existing profile, and then I will elevate it with 100 millimeters. Okay, so you will understand what I am doing when I have done it. Okay, so we'll start. So you can do it with me. Start with draw tangents. Select this. Okay, select this point, right? Then you have to provide minimum 50-meter curve. So if you are going to provide 50-meter curve, you have to keep this. That means you have to finish your gradient at least after going 25 meters. Okay, otherwise you can't provide 30-meter curve, sorry, 50-meter curve. So I'll put it like this, and I'll try to match it like this. Okay, then see, I can draw lines like this, and you have to make sure, see, you have to make sure that gradient is 3%, right? 0.3% minimum, right? But now we can't see. Later the labels will come, then we'll see. Now you need not to be precise. Of course, we can later change any of these. We are just drawing some lines. And finally, I'll finish it like this. Now can you see what happened? Some labels came. These are IP stations. IP means intersection point, right? And they give IP elevations as well, and they give what else? The gradient. Now you can see, if you are coming here, it is 47, it is 0.17. Then what happens? Okay, you cannot keep 0.17, you will have to give minimum 3%. So we'll correct them later. Okay, so please quickly finish this one. So you can put wherever you want, later we can change. Okay, now just think, you have to match this with the existing profile as much as possible. Okay, so what I'll do is I'll bring this one to 25. Why do I do like that? Then once I engage a curve of 50 meter, the curve will be like this, starting from 0. Okay, so how can I make this 25? So you can change the properties from here. See, select PVI. Once you click it, uh, dialog box will come, and once you select this one here, PVI station is there, so you can make it 25. Okay, you can make it 25. And once you take your cursor out of this dialog box and right click or press enter, this being brought to 25. Understood? Now just think, now just be familiar with this toolbar. So you can delete this IP as well. Here can you see? Now the next thing before that. Now I closed it. Now the one problem with Civil 3D is the next time I press this so many times, it is not coming. See, it's not coming. Only in the first instance it is coming. So in the next time, from the second time onwards, you have to go to this one. See, profile layout parameters. Okay. This one also sometimes you have to press 2 times. And now it comes. And then it's there. You select again this select PVI. And you select the PVI. Now it shows these details. Okay. Now suddenly you close this down. Now what can you do? You can reclaim that dialog box by selecting this profile, right click, edit profile geometry. Edit profile geometry. So the dialog box comes back. Right? And now we'll try to employ a curve here with 50-meter length. To do that, you have to get more free vertical curves from here, right? More free vertical curves, free vertical parabola PVI base. So that is a symmetrical parabola. Okay, that's a symmetrical parabola. Okay, right? Now I selected this one. It says pick point near PVI or curve to add curve. So you just select pick point near PVI and it says specify curve length or pass through K. So I'm going to specify the curve length, that is 50, and press enter. Press escape. Now you can see I created one curve, my very first curve. Okay, so there you can see IP station is 25, IP elevation is 24.631. That is the elevation of this point, right? BVS, begin vertical curve. Okay, begin vertical curve station, that is 0. Begin vertical curve elevation is 24.883, and end vertical curve, that's here, station is 50, end vertical curve elevation is 23.177. Right? What about K? K is not there. How can we get the K? To do the K, now can you see the vertical geometry is a mess? And if you check finish road level and existing ground level here, both of them are same, because this finish road level is also pointing to the existing ground level. Vertical geometry is also pointing to the existing geometry, right? So we have to change these pointers. How? To do that, you can select this grid, right click, go to profile view properties. Okay, profile view properties. And there you can go to bands. Okay, so what did I do? I selected this grid, right click, profile view properties, and then I came to bands, and here can you see the second one, that is FRLUM, that is finish road level. Finish road level, you have to change this profile 1 and profile 2. Okay, this one you have to change to FG. Here also FG. Then the second thing, 1 2 3 4, that is VGO. VGO means vertical geometry. UM is the type. VGO UM, you can, here only this one you can change profile 1, change to FG. And another thing that you have to do is you have to add here, can you see the select band style elevations and stations, you have to add one to the edge. Now don't worry much about it, you just press OK. Just select here elevation and station and press add. Press OK, and you give here -100. Now I'll explain what I'm doing later. And here profile 1 should be FG, profile 2 should be EG. Okay, so what did I do? I'll do it again. There, here you have elevation and station. Press add. Now first you have to select it, right? First you have to select it. Now if it is like this, land desktop right sample is something, don't add that. You select elevation and station and then go and add. Just press OK and give the gap as -100 and give the profile 1 as FG and profile 2 you keep it as EG. Okay, then press apply and press OK. Now can you see some changes have been made? What are these changes? Finish road level has been changed. Now this one is the just the first thing. We are going to go and tag it there. Therefore it is the same thing, but after that it is going to change. And can you see here vertical geometry is finely defined. Now here you are having a crest curve. Vertical curve length is 50 and K is 10. Now does that satisfy your requirement? For a vertical line, for a vertical, I mean the crest curve, you have to have a minimum K value of 9.84, not 9.84, 9.8 for 50 kmph speed. So now this is satisfied. Vertical curve length is 50, that is also satisfied. The minimum curve length is 50. Therefore, this is pretty okay. Right. And what is this one? This is the difference between the finished ground and the existing ground. What should be it? Theoretically it should be as much as possible. It should be near to 0, right? Because you are matching with the existing ground level. But of course you cannot have it exactly 0. Later of course because then there is no design. But you have to make it as much as equal to as much as 0. So what we did was we added that additional band here. This band is added here and this -100 is the from the edge of super elevation, how much it has to elevate itself. That's the gap between, that is the gap between uh, this super elevation label and this one. Okay, and here why I gave two profiles here, FGEG, that is so this gives finished ground minus existing ground, that is this difference. Now if you are not very happy with this one, later you can get, now for the time being you can delete it. Okay, you can select and delete it, but later of course you will have to check. Right, now the next thing, now you see you have to match this as much as possible with the existing uh, existing road. Right, now here we shall bring this into 75. Okay, I'll make it 75. Why? Because it is 50, sorry, it is 25. Can you see it is 25? So when it comes to here, it's 25, 25, that is 50, and you are having another 25 here. So the difference between from here to here should be 50. Why? Half vertical curve length here, half vertical curve length here. Vertical curve length is 50 and you are having half vertical curve length here, that is 25, half vertical curve length here, another 25, so that is 50 effectively. So if it is 25, 25 plus 50 is 75. Okay. Then what you have to do is you have to think little bit about your other IP point as well. Okay, so if you just feel you want to drag it here, you can't just drag, but there is a tool bit here. Here move PVI. Move PVI, it says specify point near PVI to move. I'll take this one, then it says specify new location. So you can bring it here like this. Okay, so you can change it like this. Doesn't matter. And what do you think? So just think that this is not matching with the existing one. So you can raise this one. How? Select it and raise it 523, that is 221.523. Say we'll give for 50, 550. Not much. Say 700. See, now it's matching. And this one, check whether it is the best place. Okay, so what I'll do is I'll make this 145. Okay, and I'll employ a curve here 50. See, and right click. Now you can see it is a sag curve, right? That is why it is coming in green color. That is how the template is set. Okay, that the IP station is coming, IP elevation is coming, begin vertical curve station and elevation is coming, end vertical curve station and elevation is coming, and K value. So when you are going down, you see it is empty. So that is some bug in Civil 3D, right? So what you can do is you can select this grid, go to profile view properties and go to bands, and without doing anything you can just apply and press OK. Then it's coming. K is 16. So 16 means what is the minimum K we want? It's 12, right? So this is 16, then this is pretty okay. Then we'll go to the third one. Okay, third one you can see it is 2.7 here, that is okay. 0.41 okay, but the problem is after that it is 0.17. This is not possible. So what I suggest is we'll give here point minus 3. To give point minus 3, one thing you can do is first we'll bring this into some proper value like 250 or 255. Okay, so I'll bring it to 250. Okay, then this one 346 something. Shall we bring this to 350? Yes, say 350. Now the problem is it is minus 46, sorry 16. So we'll make this 0.3. How? You select this one, click. Now can you see the grade in? We'll make it into 0.3. Now see what happened. There is a heavy filling coming here. So one thing you can do is it is 250, this is 350. So this is 100-meter difference. So that means you can have another curve in between. So we'll have one IP point here. Okay, in 300. So you can insert a PVI here. PVI means point of vertical intersection, right? And I'll come bring it 300 here. Right click. Now look what happened. It is 0.91. It is 0.31. It's pretty okay, right? Pretty okay. Now you can engage employ curves. Here what happened? Again here it is 0.28. This is trial and error, right? So once you do the changes, this change. So what I suggest is here we'll do like this. We'll bring this to 150. Here 150. Then okay. But one thing I can do is I can have in 200 I can have another IP point like this. Okay. Now what I do is grade out I will make 0.3% and see what will happen. Now, how is that? All the gradients are good. All the gradients are good to go, right? 2.6, 0.53, minus 0.3, minus 67, and 3.1. Okay, now it is a matter of save the drawing, right? Time to time. Now it's a matter of employing the curves. Okay, so what you can do is add a parabolic curve. Pick point near PVIO curve to add curve. Put it here. Curve length that is 50, right? And then here another 50. Now check the K. Of course, you have to check K later. What you can do is you can check all the K's later, right? Here we will give another 50 here. Okay. And another 50 here. And another 50 here. Right. Now what you do is you select this grid, go to profile view properties, apply, okay. Now check the case. Here 10 okay. Crest curve minimum is 9.8, K is 10 okay. Sag minimum is 12, we have given 15 okay. Here Zag minimum 12, we have given 24, that's okay. Here Sag minimum is 12, we have given 218 okay, right? And here crest minimum is 9.8, we have given 136, that is okay, right? The last one Sag minimum is 12, we have given 51, that's okay. And since you have given minimum 0.3, now your gradient is also okay. So up to this you have completed the designing for the time being, right? Then what is this thing? Here it is 350. So here what we'll do is again we'll do the same thing. We'll bring this to 450, 450, right? Then here at the middle we'll have another IP, and what I'll do is I'll make this grade in into 0.3, and now here it is 0.19. So what I'll do it, I'll make it, one thing I can try is I can remove this IP. Okay, shall I remove it? Using delete PVI, I'll remove this IP. Now it is 0.25. So what I can do is I can select here and give it as 0.3. Now okay, right? So now here, what about this one? Now can't I remove this IP as well? Shall we remove it and see? So it makes it better, right? Once I removed it, it becomes better. So I'll bring this IP into 520. 520. Now here I can have a curve. It need not to be only 50. It can be say something like say even 100. That is pretty okay. But only these you have to match it with the existing rod. Okay. And then we'll select this at the parabolic curve here and I'll give 100. Okay. Now even after giving 100, this is still not matched. So what if I give 150? I can change it here to 150. So it seems pretty okay, right? See how the road is being designed. And if you want to check the K value, profile view properties, you can apply. Okay. K value is very big, 150. But once you increase the K value, the problem is, in a crest curve, if you are going to increase the K value, that means this is going to be somewhat flat, right? So then there comes some drainage problems. So you have to keep that in mind, right? If you can give say something like K equals, now here it is 178, right? So sometimes it comes like K value as 1000, 2000, something like that is coming. But then of course you have to have precautions for the drainage because this area is flat. There will be no water flowing, right? And here we'll bring this one into 610. 610. Okay, now I think I can raise this a bit. 197, that is almost 900. So what about 950? Seems pretty good, right? No, say 960. Okay, then we'll give a curve here, say 50. No, you can give a bigger curve, something like say 80. 80 seems pretty okay, right? And here you have to consider all these three things before going for a solution. Okay, 765. We'll correct it, 765. Okay, and this one will take into 690. Now our gradients are pretty okay. So we'll start giving a 50 curve here. And here of course, can't we raise this a bit? 392. What about 420? Oh, 500? Because since this gradient is high, you can try. What about 600? Now okay. Then you can employ a, sorry, more free vertical curves, free vertical parabola, but once it's been selected, it is coming here. You can just click it and take. Okay. And 50 here. So you can increase the curve length, say 80. 80 seems pretty okay. Right now, this one of course will bring into 820. 820. Right, and then this one 910. Okay, 910. Now here it is 0.88, that is okay. Here it is 0.22, but if we give zero point 0.3 here, point minus 3, minus 0.3, right? Then we'll have a curve here, say 50, and here also say 60. Then of course it's not going to match. Okay, so if you want, you can delete this curve as well using this toolbar. Right, so maybe you will have to try designing this in a different method, like say, can't I have an IP here? I have to give minimum 50, right? 10, 20, 30, 40, 50. So it is something like this. Okay, now what you can do is, now you can raise this one a bit, say 19300. How about this? And you are going to have 50 here, and here 1 2 3 4 5. So you have to have this, you have to bring this IP here, 920. Okay, now instead of this 10140 you can remove this IP. If you are going to remove it, you can bring it back here, just like a riddle. Can you see? 910. Okay, so I'm not going to go beyond this. I'll stop from 900 uh, because we have to go for the cross sections, right? So what I'll do is, I'll have a curve here, say like 50, and then I'll stop here. I have designed only up to 900. Okay, this is not design, right? Just we are wasting time in that case. So after finishing this one, what we can do is, we can raise this profile by 100 millimeters. See, so what we'll do is, I'll go to profile geometry, and then can you see here, this one, raise lower PVIs, all PVIs. I'm going to elevation change, I'll give zero point 0.1, that is 100 millimeters. Okay, and then right, later if you want to check the difference between the vertical one, so the design one and the existing one, what you can do is, you can check it using profile view properties, and then here you select this elevation and stations, add it here, and give say something like minus 200. Here this one FG, this one EG, apply. Okay, it is, we'll make it 150. Now you can see some are okay, right? But some you are having some high values. Okay, sometimes they are unavoidable. Okay, sometimes they are unavoidable. Now I'll share this with you so you can try the cross sections with me. Profile today is 25th, right? 25th 9 2024. Okay, now after that again open Civil 3D. And then you can open the one that we did. Open, that is a desktop UM day2 profile. Continue with current command, right? Then you can save this as CSS file, save as. So you create another folder day3, day3, and go inside it and then make it as CSS and save. Now after that what you are supposed to do is you have to change the scale to 1 into 50. Okay, 1 to 50, right? And now we are going to create the relevant assemblies and sub assemblies. So what we are going to do is we are going to recreate the road here using assemblies and sub assemblies. Now if you don't understand what are they, don't worry, you will learn soon. Okay, so an assembly is something that we are modeling as a say center line or something. Okay, for the time being you just think it like that, later you will understand what's that. So you can go to here, corridors, create assembly, corridors, create assembly. Then you have to give a name. I usually give CS. And assembly type, you have to select undivided crown road because your road is undivided. That means you don't have a center median. Other one is crown, that is it is not a flat one. Crown means you have cross fall, right? So it is undivided crown road. Assembly style is assembly. Code set style is finish. Okay, then press OK and keep your assembly somewhere near this profile. Why I am telling you is like this is say it is very small, otherwise you will not be able to find it. So usually what I do is I draw a circle around this, like this. Okay. And can you see that small circle? You want this, right? Now our road, if you are going to look at it, can you see our road? We are having, what is this one? That is a lane and hard shoulder. After that, of course, we can have soft shoulder as well. Okay, so we'll have lane here. Okay, so for this, I'll get general tool palettes window. Now just think that what I am doing is I am just drawing the typical cross section of the rod. Do you know what is typical cross section? Just the cross section typical. Okay, so everywhere when you are going to design a road, you have to give a typical cross section. Just think what I am doing is using the Civil 3D tools, I am just going to draw typical cross section. For the time being, you just think like that. That's enough. Then you go to General and Tool Palettes window. And here you are getting this toolbar. And there you can go to, can you see there's something called lanes? Here, lanes. Now, if you are referring my book, it is teaching another method, and I am not going to repeat that because you can just because you see in that book this road is considered as a rehabilitation project. Okay, but if you are going to consider this as a rehabilitation project, of course, so there are a lot of other theories have to be covered, and we'll have to have some more time. Okay, usually in other places I am going to finish this one within 16 hours. Since we don't have time, we'll just consider this road as a uh, new road. Okay, now for the up to the vertical profile, it doesn't matter whether it is a new road or a rehabilitation road. Everything is similar, but once you are going to show the cross sections, it matters. If it is a rehabilitation road, it is bit different. If it is a new road, it's bit different. So we'll take it as a new road, but anyway the finish levels, that is just a difference in the picture, but the finish road levels and existing road levels will be same. Okay, so you take lane outside super multi-layer. Lane outside super multi-layer. Okay, so what did I do? I went to general, uh, tool palettes window, and then I came to lanes, and then I took lane outside super multi-layer. Okay, then it says select marker point within assembly. So it is like this. Okay, it is like this. So there it came. Now you select this lane. This is the lane, right? First lane in the RHSI. So you right click it, go to sub assembly properties, and give the, you change the name lane outside super multi-layer slash dash R. Then parameters, of course you have to give. What are these parameters? Just think, if you are having any problem with the parameters, you can go to sub assembly help here. See, it shows everything, and the description is also there, right? But don't worry, we can just fill these things. Side is R, right. Insertion point crown, that is okay. Crown point on inside, does the crown point come inside this lane? No. Width is 3.5, right? Default slope, Sri Lanka default slope is minus 2.5. Super elevation slope, you can select and go and say right outside lane. Okay, and lane slope direction away from ground, that is okay. Pave 1 depth, that is varying cost, say 40. Pave 2 depth, that is binder cost 60. And pave 3 depth 0. Base depth, there are no base depth. Whatever subbase depth, no such subbase depth. Okay, now you can press apply and okay. Hey, what happened? Pave round depth is 0.040, right? Okay, so this is the edge of our right hand side lane. Okay, then what you can do is you can mirror this one. Okay, you can mirror this one. How? You select this one. Can you see there's mirror? Select the mirror. Then it says select marker point within assembly. So you have to select this marker point. Are you sure you want to mirror the sub-assembly to the same sides? Say OK. Now it is being mirrored. And you have to select this one and go to sub-assembly properties and check if the parameters are correct. Lane outside super multi-layer, it is not R, it should be L. Okay. Then go to parameters. Side is left. Insertion point. Now there is nothing you have to change here except the superelevation slope. It should be left outside lane. Okay. Apply. Okay. Then you have created the lane parts of the road. After that, what do you get? That is the hard shoulder, right? For that, so we'll get hard shoulder. To get the hard shoulder, you have to select shoulders and you have to select shoulder vertical subbase. Shoulder vertical subbase. Select marker point within assembly. This one. Escape. So for the shoulder, we'll give 50%, sorry, 50 millimeter, sorry, 40 millimeter wearing course, and then 60 millimeter binder course, and 150 ABC and 300 type 1. Okay, shall we give like that? Right. Then you select this one. Now here you can see there is one hard shoulder and soft shoulders. Hard shoulder is 1.5 meter. We'll take soft shoulder as 2 meters. Okay. Width, right? Then select this hard shoulder. Go to sub-assembly properties. Shoulder vertical subbase. Say dash R. Parameters. Side is right. Paved width. It is 1.5. Use super elevation slope. Say right outside shoulder. Shoulder slope direction away from ground, that's okay. Default paved slope, it is minus 2.5. Unpaved link treatment, you keep it as it is. Unpaved width is 2. Unpaved slope is minus 4. Now if you have any problem here, what is this unpaved link treatment? You can go to subassembly help and check. Okay, so what is unpaved link treatment? Here determines when or if the unpaired portion of shoulder is inserted. 1 is always used. That is why we keep it as 1. Okay. Because if you are getting a cut, sometimes we don't allow. That is why. So you can keep it as it is. Unpaired slope is 4. Unpaired maximum breakover means. Now last day I told you, no, because when it comes to superior sections, you don't give the same slope to the soft shoulder. Then what happens? If you give the same slope to the soft shoulder in the super elevated sections, what will happen is all the debris will come to the road with rain. So what we do is we give the slope the opposite direction. Okay, we give the opposite side. I mean, if your super elevated side is say, if your super elevation is 2.5 upwards, your soft shoulder is say sometimes it is like say 4% downward other side. Okay, so what it says this maximum breakover means now you see the super elevation is plus 2.5 and then your uh, soft shoulder is minus 4. So what is the difference? 6.5. So the maximum breakover is, so it should not go beyond 8. Say something like this. So you just think, say, if your superannuation is 4%, and then your soft shoulder cross fall is minus 4%, so it comes like 8%. So that is the maximum. Okay. So you keep it as it is. Then pave 1 depth, that is 400. Pave 2 depth, that is binder cost 60. Base depth, sorry, you have to keep it as 060, right? And then base depth we thought 150, sub base 300. Apply OK. Now this is your, what is this one? This is your shoulder. Hard shoulder, this is soft shoulder. Then you can, sorry, then you can mirror this also. You select this and go to mirror. Now remember, select marker point within assembly. Don't select this one as AutoCAD. You go and select the point that you want to join it here, right? Not somewhere here, right? Don't try to go here and here like AutoCAD. You have to select the point where you want to attach this one. Then you can change whatever necessary. Right click, go to sub-assembly properties. So this is of course L. When it comes to parameter, here use super elevation slope, left outside shoulder. Okay, then press apply. Okay. Right. Then this is about cutting and filling. For this you have to go to daylight. Here daylight multi-intercept. Select this one and says mark point within assembly. You select it. Escape. Now select this one. The daylight, right click, sub-assembly properties. Here you don't have to change the name. When it comes to parameters, you have to change only two places. Cut slopes, it is 0.25 to 1. Fill slope, it is 1.5 to 1. So that is the RD standard. Okay, general standards. So it's like this. What did I do? I select this one. Went to select similar, sorry, selected this one, and then I went to sub-assembly properties and then went parameters. Here only these two I have to change: cut slope and fill slope. Okay, cut slope is 0.25 to 1, fill slope is 1.5 to 1. Then press apply and OK. Then you have to select this one and again you have to mirror it. Mirror here. Okay, now you have created your assembly. Save the drawing. It is just like that you have created a typical cross section of your rod. Now we are going to run this one along this rod. That is what you call creating a corridor. Okay, now what we are going to do is we are going to run this typical cross section along this rod, and that is what you call creating a corridor. Okay, so for that you go to corridors and create corridor. Okay, corridors, create corridor, and then you have to fill these things. Name, usually I give. So what you can do is, usually I give CSS. You can give whatever you want. And corridor style is basic. Baseline style is alignment and profile. Alignment is DCL. Profile is FG. Okay, so that means our finished ground profile. Assembly is CS, the one we created. Target surface is, sorry, target surface, of course, that is EG. That is the only surface that we are having for the time being. Now check whether you have corrected these things. Name should be CSS or whatever you want. And then corridor style should be basic. Baseline type is alignment and profile. Alignment is DCL. Profile is FG. Assembly is CS. And the target surface is EG. Okay. And now press OK. Right. Then you can see the CS, they are going to run it from 0 to 1179, but of course we design it up to 900, right? So we'll make this 900. And frequency, you can click this one and it says the at what levels, at what intervals you have to create this corridor. So along tangents it should be 10. Usually we get 10 meter. Curve increment, it's 10. Along spirals, we don't have spirals. At horizontal geometry points, no, we don't give any special points. Okay, vertical curves also 10. Vertical geometry points, no. At high low points, no. Offset target points, no. Adjacent to offset target points, no. Only you have to give this 10-meter interval. So we are going to run the corridor in 10-meter intervals, or interval only. Then that's all. Okay. Then press OK. Right, and then target. So you can go to, so what did I do? You can go to target. So it is asking lane outside super multi-layer. You remember what they are asking here? What they are asking is, sorry, you have to check with target. Okay, what they are asking is, this is LHS side. So what should be the alignment that you have to target? What is that alignment? DLHS. Do you remember that? Within 3.5 away, sorry, from the center line, 3.5 away, what was that alignment name? It is DLHS. Okay, so you select this DLHS. Lane outside super multi-layer R, that is RHS side. Go to with target. So this one DRHS. Remember. And hard shoulder, it is, this is L, so it should be HLHS. And this is R, so it should be HRHS. So you can refer the book, right? If you are following the book, then of course it is easy for you, because this is something that we did last time. I can't show it because Then later I'll show. Okay, now I can't show because if I am going to show it, what happened is I'll have to this from the beginning. Then you go to surfaces. The target surface. Here you can set all to EG. It is already set, right? So no harm. Then press OK. Apply. Repeat the corridor and OK. Now you remember that here this is DCL, right? So within 3.5 length it is DLHS. After that it was HLHS. Here within 3.5 meter length it was DRHS. After that 1.5 it is HRHS, right? So our corridor is being created. Now can you see in some places you are having some cutting and filling as well. Here can you see it is not homogeneous, right? Here can you see here some filling is coming. This terrain is fairly flat, okay, so you don't have much difference, right? Now your corridor is being created. Now after that, one important thing that you have to do is you have to go to your tool space. If it is not there, you can get it from general tool space and go to these corridors and go to the prospector and then corridors. So expand the corridors. Here the CSS, right click, go to properties and then come to surfaces, and while the data type is links and specify code is top, you add create a corridor surface, and here you can add this links and top. So here what we do is what we did was we ran our corridor, or this what you call this assembly along this corridor, and then we created it is top surface. Its top surface is our finished ground. Do you understand? We ran this assembly, or just think it is a typical cross section along this corridor, and then later we created its top surface. Its top surface is what we want, that is our finished ground, the finished road level. Okay, now the next step is we are going to cut this corridor just like you are cutting a cake. We are going to cut this corridor in 10-meter intervals. Okay, for that there is a tool here. You have to use sections, create sample lines. That means the places where you are going to cut that. Just think now that this corridor is like a cake, right? So it is being created. Now we are going to cut it to see the cross section. Okay, create sample lines, and once you get this cursor, right click, select alignment. You have to select our center line alignment, DCL, press OK, and give this name as SLG1. Sample line style is sample lines. Sample line label set is name and section marks. And here second one, CSS, you have to make it finish. Okay. So these are the only changes that you have to do. Name is SLG1. Sample line style is sample lines. Sample line label set is name and section marks, and here you have to change finish. Press OK. And then you come here and take by range of stations. By range of stations. Now you have to give these details from alignment start. Yes, true. To alignment end, no, we are only going up to 900. So you make it false and make it 900. Snap to an alignment, that is false. With this LHS side, the width that you want as the cross section. So we'll give 15 meter, right? Right, swap this snap to an alignment false with this 15 meter. Sampling increments, increment along tangents, we'll give just 10 meters, right? At range start true, at range end true. Please correct these things. Okay, from alignment start true. If you want, you can make it false and start it from somewhere else. Say if you want cross sections from 100 meters to 200 meters, you can do it like that. Okay. Then width is the width from the center line. Right? Okay. Then press OK. And it says specify station along baseline. Put your cursor here in the command line and then press enter. Now you can see these are the places where you are going to cut your corridor and see the cross sections. Save the drawing. Okay. Now somebody's mic is switched on. Please switch off that, right? Okay. Now we'll go to create cross sections. So for that, you go to sections, create multiple section views. Sections, create multiple section views. Then there's nothing you have to change here. Select alignment DCL, sample line group, that is the one we created, SLG1. Station range, of course, that is not for the whole area. We are going to go for 0 to 900, right? And we give this section view name here as S1, and section view style, we'll go to road section, right? Then press next, and in the somebody's mic is switched on. Please switch off that. Okay. Then we'll go to here placement option draft, and group plot style is plot style. Okay. Then press next. Offset range, it is from -15 to +15. There's nothing to change. Then press next. Elevation range, of course we cannot say for the time being. Elevation range is from here to here, right? So we can't say it now. Press next. Display options, here you have to remove this CSS tree. Okay, just untick it. Okay, then press next. Data bands, of course you have to get cross sections. Here it says FG elevations, that is the CSS stream is the new surface that we created. You remember that using the corridor, we created another surface. I told you that is the topmost surface of the road. That is this one. So that is FG elevation is okay. EG elevation is EG, EG. Offsets, of course, you can keep it as, because if you are going to keep it as CSS, CSS3, so you are measuring from the center line. Okay. Then press create section views. So it says identify section view origin. You give some uh, location that is that you have enough space. Okay, otherwise it will go on top of this. Right, now you can see that your cross sections are being created. This is how they come. See that even that super elevation is also shown. Okay, here it is super elevated. Right, now this area is the existing one, and so I mean the lanes, and after that here you have the hard shoulders. Okay, and then the soft shoulder, and this is filling. Okay, here there is some little cut also. Now can you see that here this is super elevated and this soft shoulder is not going into plus 2.5, instead it is coming to 4%, the other way around. Okay, that is the maximum breakover. That is what they are meaning by maximum breakover. Okay, here you can see everywhere there is super elevation, your uh, soft shoulder is turned other way around. Okay, so you can check here. Now there is a cutting also. Okay, and here there is a filling, cutting here, filling here, like that. But you are having some super elevation transition here. Okay,